Okay, so in order to be able to find the specific volumes given a P and a T, pressure and temperature, we need to be able to solve the roots of a cubic equation. And so we're going to do that by starting out by defining a cubic equation. So cubic roots. Cubic roots, and we want A, B, and C. And so I always forget this. And so the first thing I have, again, on this board of trusty equations from the internet, I have Q is equal to A to the third, no, A squared minus 3B over 9. And then the second thing that's going to help us out is R is equal to A squared minus 9AB plus 27C over 54. And that is not helpful. I need 2A squared. There we go. And so with that, there's a stipulation that if you're going to be solving for Q and R or that if you're going to be using Q and R, if R squared is greater than Q cubed, then we have this theta value is equal to the inverse cosine R over Q to the 3/2. And then another value, R1, well, these are actually all the roots. So we're going to do an array for the roots, which is just R's. And that is going to be equal to, what? Oh, it's numpy.arccos, so it's np.arccosine. There, okay, now it accepts it. Okay, it got it. It got there eventually. The roots are equal to, all of them start with -2 times Q square root of Q, so negative square root of Q times numpy cosine of the first one is, and this is where the list or array comes, well, it's not going to be an array because numpy doesn't support arrays, so it's going to be a list of theta over 3 is the first one, and then the next one's going to be theta plus 2 times numpy pi. The next one's going to be theta minus 2 pi. And then it's all going to be minus A over 3. And then we're going to want to return the sorted roots. So that's going to be numpy dot sort roots. And then there's another, and then if that's not a case, so then we're going to be else. We're going to have an A function, so there's going to be an A is equal to expected identification. You don't know anything. Expected expression. Oh, is it? Okay, hang on. So if... There we go. There we go. Okay, so it's not capital IF. Okay, so then A is equal to the... Actually, this is going to be the sign of R, so numpy dot... No, it's going to be equal to the negative sign of R. So negative numpy sign of R. Probably hear the lovely, lovely rain behind me. Times the numpy absolute. I'm going to guess that's... should be absolute. It's the numpy absolute value of R plus the square root of R squared minus Q to the third to the 1/2, or just the square root of that, to the 1/3 power. And I need to put a, I need to put a multiplication symbol there. And then B is going to be equal to the, well, B has an if in and of itself, so B is equal to 0 if A equals 0, or else it's going to be Q over A. And then that is going to return this x value, and that is A plus B minus A over 3. And there we have our cubic roots. And of course there's already a problem. I guess I probably forgot some... Okay, so what's the problem? Invalid syntax. Okay, plus 27 times C. Okay, and then the next thing to do is we're going to have to make a cubic volume. So we're going to define a cubic volume, cubic, and this one's going to be cubic V of R and T. No, P, not R. And in order to define this, we first need to do A, B, we're going to need to do A, B, epsilon, and sigma is equal to cubic apes of T. And then so after we do that, we're also going to need the beta, which is B times P over R times T. And then we're also going to need Q is equal to A over B times R times T. So once we have that, we can do the compressibility factor is equal to the nice big long thing we did last time is equal to cubic roots of, and I believe it is, so A is going to be the z squared, which is epsilon plus sigma times beta minus 1. And I think I'm actually going to need a bracket here because this is going to be, no, I don't need a, we'll see if I need a bracket later. Epsilon times sigma times beta to the second plus q beta plus, no, minus epsilon plus sigma minus epsilon plus sigma, no, epsilon plus sigma minus beta squared. And the third one is, these are all negative, so it's negative q times beta minus epsilon times sigma times beta to the second, and then minus epsilon times sigma times beta to the third, not beta, beta. And then we want this to return V, and V is equal to Z times R times T over pressure. Okay, and so to check this, we do cubic V and 1 e to the 7th and 1 e to the 7th Pascal and 600 Kelvin. And that should give an array. Okay, looks like I gotta go back and do some stuff, so let's see. Okay, so this, please let this be the, no, I don't want to replace all of that. Please let, okay, it's fine. Please let this be the groundbreaking discovery of some sort. No. Okay, I have found another potential error. I think this is supposed to be cubed because I was been looking at the R function. So let's see if that changes anything. Well, it changes the number, but it doesn't change what I want it to change. Okay, after some more looking around, I have realized I made a big boo-boo here. So this is supposed to be over 3, and this is also supposed to be over 3. So there's that. Don't think that's going to change anything because it didn't change anything before. No, it's still probably going through this thing, which is not what I want. I want it to go through this. So it's still something wrong in this cubic roots because everything above here is correct. I have verified that. So it's problems are in here. I just got to find them. Okay, so I was right the first time I did this. It's to the 1/2 as I thought. And then all of this is to the 1/3. So let's see, because this is the square root of this. I think this should do it. Okay, well it did something. So I remember something about that all having to be over 54. Okay, so I verified that. Then this is now correct. So it's this part. Beta squared q beta minus ES beta. Okay. Still wrong. Oh, it's q times. It is q times beta squared. Okay. Okay. There we go. There we go. So that is how you find these are all specific volumes for these listed. I guess this is just these are the roots, but this is how you would find it given a p and a t. This is how you'd find specific volumes because it does return a list of specific volumes. So it's something along those lines. I'm not completely sure if I'm done with this one. I'll have to check, but for now, I've at least found that problem, so I can continue.